While global attention remains fixed on the battery range and charging capabilities of prominent electric vehicle manufacturers like Tesla and BYD, Mercedes-Benz has executed a quiet yet seismic shift within the automotive sector. Without a major publicity event, the company has confirmed the transition of the YASA Flux motor from industry rumor to tangible reality. This development represents far more than a simple component upgrade. It is widely regarded as a foundational shift, capable of overturning the existing electric vehicle paradigm. The core proposition is an engine that is simultaneously smaller, lighter, and more powerful, a combination that prompts a fundamental re-evaluation of electric vehicle design and performance. This motor operates on principles distinct from conventional electric motor technology, leading Mercedes to view it not merely as an improvement, but as the essential backbone for its future electric mobility strategy. The revelation is particularly striking given that Mercedes has been developing this technology discreetly for a considerable period, choosing only now to unveil it officially. This move suggests a deliberate strategy to challenge the technological leadership of established EV pioneers. The potential of this technology to concurrently transform vehicle pricing, performance metrics, and aesthetic design forms the central intrigue, prompting a deeper examination of Mercedes's underlying ambitions and the reasons this innovation has unsettled the entire industry, signaling what many believe is just the beginning of a broader transformation. The entity known as YASA represents a radical departure from conventional electric motor manufacturers. Founded from a university laboratory in the United Kingdom, the company is built upon an engineering-centric philosophy that prioritizes solving fundamental problems over following market trends. While most of the industry focused on incremental improvements to existing motor designs, YASA pursued a complete reimagining of the electric motor's architecture. This approach distinguishes YASA from typical suppliers. It is a company driven by the question of how to make electric motors fundamentally better, not by what the current market demands. The hallmark of its technology is the Axial Flux design, which contrasts sharply with the common radial flux motors used in most electric vehicles today. The principle of small size, big power encapsulated by the YASA Flux motor is the central reason it is considered a game-changer. Its compact dimensions directly benefit vehicle design, liberating engineers from the packaging constraints imposed by bulkier traditional motors. This allows for lower floor pans, more spacious interiors, and sleeker, more aerodynamic exterior profiles. The reduction in weight is equally transformative, as a lighter vehicle inherently offers improved range, sharper handling, and more responsive braking, thereby increasing driver confidence and engagement. The motor's ability to deliver substantial power from a small package stems from its exceptional efficiency in energy conversion. By minimizing parasitic energy losses, particularly heat, more of the battery's energy is directed to the wheels. This efficiency translates into the immediate and seamless torque delivery, for which electric vehicles are known, but amplified, providing instantaneous response for city driving and confident overtaking on highways, all while maintaining a smooth and controlled power curve that reduces driver fatigue. Furthermore, this efficient operation has a direct and positive impact on the vehicle's battery system. By drawing power more intelligently and generating less waste heat, the flux motor alleviates stress on the battery. This not only maximizes the usable range from each charge but also promotes better long-term battery health, potentially preserving its capacity and lifespan over many years of ownership. Mercedes-Benz's strategy in embracing this technology extends far beyond a simple component upgrade. Historically, the company has maintained deep control over the core technologies that define its vehicles, such as engines and transmissions in the internal combustion era. In the electric age, Mercedes seeks to establish that same level of mastery over the electric drivetrain and its associated software. Relying on external suppliers for key components like motors creates vulnerability to supply chain disruptions, cost fluctuations, and technological delays. By securing and integrating a cutting-edge motor technology like YASA's, Mercedes aims to control its own technological destiny. This move is a long-term investment for the coming decade, anticipating a market where true differentiation will stem from proprietary core technology. For Mercedes, luxury is increasingly defined by the seamless and refined driving experience. Attributes like silent operation, smooth power delivery, and dependable range that are directly enabled by advanced motor technology. Controlling this technology in-house is therefore essential to upholding and evolving its brand promise in the electric era. The confirmation of the YASA Flux motor's production readiness serves as a pronounced wake-up call for current EV market leaders, Tesla and BYD. Up until now, the competitive landscape has really been defined by Tesla's strengths in performance and software integration, and BYD's dominance in battery innovation and cost-effective mass production. But now, the Flux motor introduces a whole new dimension to this rivalry, shifting emphasis toward motor quality, overall drivetrain efficiency, and the holistic driving experience. For Tesla, the challenge lies in the potential erosion of its technological leadership in powertrain design if a competitor can match or even exceed its performance and smoothness with a more advanced motor. For BYD, which has competed effectively through scale and battery technology, the emergence of a motor that extracts greater range and longevity from a given battery size could alter the economic equations of its strategy. The competition, then, evolves from a focus on battery size and charging speed alone to a more integrated contest of complete vehicle efficiency and sophistication. This development pressures all major players to accelerate their own innovation cycles, transforming the EV race from a sprint for market share into, really, a marathon where sustained technological advancement in all systems becomes paramount for survival and leadership. So, regarding implementation, Mercedes' rollout strategy for the Flux motor will likely follow its established practice of introducing groundbreaking technology first in its high-performance and flagship segments. The Mercedes-AMG division, which serves as the brand's proving ground for new technology, is a natural first home for the Flux motor. The motor's attributes of high power density and low weight align perfectly with AMG's performance ethos, promising even more aggressive acceleration and sharper dynamics for its electric vehicles. After that, the technology would filter into Mercedes' premium electric sedans and SUVs within the EQ lineup, enhancing their refinement, range, and distinctiveness in the luxury segment. This phased approach allows Mercedes to validate the technology in real-world conditions with customers for whom cost is a secondary concern, while also driving down production costs through initial limited-scale applications. The lessons learned and economies of scale achieved in these premium models will then pave the way for the technology to eventually reach more mainstream Mercedes-Benz electric vehicles in the future. The question of affordability and broader market impact, honestly, follows a historical pattern observed across automotive innovations. Technologies like anti-lock brakes and airbags, for example, initially debuted in luxury vehicles before becoming standard in mass-market cars. The Flux motor is expected to, traverse a similar path. At first, its production complexity will confine it to premium-priced vehicles. However, as adoption widens and manufacturing processes mature, costs will inevitably decrease, enabling the technology to reach mid-range electric vehicles in the coming years. For the average consumer, this progression means that the benefits of enhanced efficiency, longer range, and superior driving smoothness will eventually become accessible. If the value proposition, like tangible long-term savings from better battery preservation and increased efficiency, is clearly communicated, customers may, in fact, demonstrate willingness to pay a modest premium for these advantages. Looking toward the next 5 to 10 years, the widespread adoption of technologies like the Flux motor could, honestly, fundamentally reshape the electric vehicle industry. The most immediate change would be in vehicle architecture, with lighter and more compact drivetrains, enabling greater design flexibility and efficiency. This could also influence the industry's supply chain dynamics, potentially reducing the overwhelming focus on battery raw materials by making energy usage far more efficient. Ultimately, the technological race would expand beyond a singular focus on batteries to encompass a more holistic competition involving advanced motor design, software integration, and the overall quality of the driving experience. This shift would mark the evolution of electric vehicles from appliances defined by numerical specifications to sophisticated machines where the experience of driving becomes a primary differentiator, heralding a new and more mature chapter